Hello and good morning, everyone. Welcome to Autodesk Virtual Academy, brought to you by your friends here at KETIV Technologies. I'm Nigel Umbayak. Welcome, everybody. And today we're going to be going over 3D annotation and model-based definition with my friend here, Alex Alvarez. How's it going, Alex?
Not too bad. Not too bad.
Awesome. So if, everything's the same as it usually is, if you have any questions during this, go ahead and post them into our chat panel here, and we're more than happy to go ahead and take a look at those and answer them for you during the session or at the end during our dedicated Q&A portion. So with that, I think that's all that I have. Alex, do you have anything to add before we get started here?
No, just looking forward to going over this topic with everyone and hopefully showing a few unique things inside of Inventor.
Absolutely. So with that, Alex, go ahead and take it away. I will go ahead and let you have the floor here.
Awesome. All right. So before we do get started, kind of want to share with everyone, all of our viewers, a little bit of what's going on with KETIV in regards to some of the events that we're having. So, if you guys are brand new to KETIV, or maybe you just are, one of our customers already, we like to host events year in and year out, kind of depending on different topics, feedback from different customers that we get. If you guys are ever curious as to what events KETIV has in store for everyone, if you can just go to ketiv.com/events. That'll give you essentially a list of all the different events that we have. So some of the ones that we have, I'm going to see if I can pull some up here. And I believe Nigel's going to show he's going to attach the link there. But just to give you guys an idea of what kind of events we have, right? So we have the Autodesk Spin for Plant Design webinar, KETIV Inventor Insider. So this is actually going to be a pretty big event for us. It's going to be a live event. So if you guys are local to Orange County, if you guys are interested in, seeing what's going to be inside of the next release for Inventor, or maybe just get a little bit of feedback, this is going to be a perfect opportunity for you guys to kind of tune in and meet some of the Autodesk folks here and the KETIV folks. So again, feel free to take a look at the link here. We do have kind of a lot more going on throughout the year. So we also have ANSYS events if you guys are interested in ANSYS events or ANSYS simulation. We also have those events lined up as well. So again, feel free to look through the link, and then feel free to sign up for some of these events that are important to you guys. So I'm going to go ahead and close this out. Again, for today, we are going to be talking about model-based definitions. So again, the why as to why we're doing this, really the biggest thing is going to be to increase design and manufacturing efficiency and accuracy, right? So I say that a lot often in my webinars, if you guys have been watching a few of them. But really, this is going to be one of the main components that I feel ties both design and manufacturing together. And you guys will kind of see why that happens a little bit later on. But another really important reason why is you want to make sure that you create a fully defined 3D model. And again, fully defined might be a kind of a new terminology for some of you guys. And we'll see some of the criteria that it takes to create a really fully defined 3D model. And obviously you want to get components ready for production cycles. Again, now this is a kind of a new way of thinking. Again, this is, if you guys are familiar with some of the buzzwords out there, so Industry 4.0, kind of smart manufacturing, all these different buzzwords are going to be kind of tied to this, this aspect of model-based definition. So if we take a look at what model-based definition is, and I'll kind of refer to it as MBDs from time to time. So if you hear me saying MBDs, that's what I'm referring to. So really MBD refers to just a fully defined 3D model. Now this 3D model can consist of really just individual components or just complete assemblies in that sense as well. Now the information that really aids in building this fully defined 3D model is kind of listed here, right? So really, for the most part, with the exception of maybe 2 or 3 of these, everyone that's working inside of Inventor, for the most part, has created, almost a fully defined 3D model. Now, what I mean by that is, the metadata, the properties, usually that's already given. GD&T. Now, when it comes to GD&T, tolerance dimensions, surface finish, that's generally done in the 2D drawing environment or the 2D drawing aspect. here, though, we want to kind of show what that looks like inside of a model-based definition, right? Or inside of the actual part itself, without necessarily having to create that 2D drawing. So when you combine all these things, what do you really get? Well, you know, you're left with essentially a model that's ready for production without the need of a 2D drawing, right? Or without the need for a 2D drawing. And that's really where kind of the Industry 4.0 aspect, if you will, is kind of leading this on, right? So smart manufacturing, kind of having a single part, single source of truth that's driving all of this different information. So we're going to take a look at this little chart here. So DCC essentially stands for Data Set Classification Code stages. So again, DCC1, 2D drawings, right? This is your basic AutoCAD stuff. DCC2, again, 2D drawings, but it's referencing a 3D model. So that's typically what we're already used to. Now, DCC3 and DCC4 is kind of where we're heading at right now, or that's kind of where we're at right now. So I mentioned right earlier that while the ultimate goal is to eliminate the 2D drawing altogether, I don't think we're quite there yet. So again, that is going to be the ultimate goal, but as far as what's capable or some of the capabilities inside of Inventor, I don't believe we're quite into the stage 5 here. So we are going to be more into the stage 3, stage 4, essentially having a combination of both, right? So having a model that has some of these model-based definitions, but also attached with a 2D drawing as well. And again, so kind of show you guys what model-based definitions look like. The goal is not going to be to just add annotations and add model-based definitions to the entire model, right? So this is going to be useless. This really doesn't tell the end user anything. Now, what I like to tell customers is keep in mind as to what's going to happen with this model. Is this one, is this specific model going to be used for production? Are you going to be using it for inspection? And with that in mind, then you kind of want to start taking into account, okay, well, what annotations or what model-based definitions do I really need to add to that model? So we can see here, this is a much cleaner one. It has limited annotations, but again, it gets to the point. It has a couple general notes here to kind of take care of some of the inconsistencies or something that's unspecified. So that's kind of what we're going to be looking at today. Now, again, feel free to ask questions like Nigel said. So we'll either answer them during the webinar or we'll go ahead and at the end take care of those questions. All right, so before we do get started, this is going to be a disclaimer. This isn't going to be a GD&T class, right? So I'm not going to show you guys the proper way to apply GD&T. I am just going to show you guys how the model-based definitions work, how to apply them, kind of some of the new features that are essentially built into the software here. So again, just a quick disclaimer out there. So again, when we're working inside of the kind of the 3D modeling environment, again, this is from Inventor 2018 and forward, right? So if you guys are using Inventor 2017, you guys won't see some of these tolerance features and some of these annotations that you see here. But anyways, when you're ready to kind of move forward and start the annotations, notice that you have some of these new features inside of the Annotate tab. Again, you can start going over here and just hovering over some of these commands. So kind of like everything inside of Inventor, you kind of get a quick description and a preview of what this command is going to be doing. So this is exactly what we want for this case. So we want to go ahead and start applying a tolerance feature here. Right, so in this case, I'm just going to go ahead and first start off with the datum. So kind of similar to how you would do, some of these annotations in the 2D drawing. You want to start off by referencing your datum. I'm going to go ahead and say that this bottom face or surface is going to be my starting point here. Right, so I'm going to go ahead and accept that. Notice that it gives me it selects a plane based off of where my ISO view is going to be at. So I'm going to go ahead and just place this location here. And it gives me kind of a list of different commands here, different options that I can select from. Now, in this case, like I said, it's just going to be my datum reference, or it's going to be my datum surface. So if I take a look here, right, so we have the flatness here. So I'm going to go ahead and remove the control frame, and that just leaves me with the single datum itself, right? So I'm going to go ahead and accept that. And a little bit more information comes up, right? So this little the dialog box or the browser here comes up, the tolerance advisor browser comes up, and essentially it tells you, it's kind of walking you through some of the tolerance features that you're adding. Now, again, keep in mind that this is an advisor, right? So, just because you see question marks here doesn't necessarily mean that you're doing something wrong. Think of it, as it is. It's an advisor, so it's just letting you know, hey, you might want to check this or double check that. Doesn't necessarily mean that it's going to be incorrect, right? So we place the essentially our datum here. Again, you can click on it, you can click and drag, moves around a little bit, right? It's kind of depending on where you place it, you're only going to be limited to a few selections. You can change planes as well, so we'll show that a little bit here down the line, but essentially that's going to be our first step, right? At least for me. Next step, again, I'm going to go ahead and add another tolerance feature. Go ahead and click here. And again, I'm just clicking on the surface. Whether you want feature priority or feature size priority, that's kind of depending on what the selection is. So I'm gonna go ahead and click on this, right? And then we have an automatic profile feature created, right? If we click here, we have a few different options that we can select from. So we can either select flatness, the profile of a surface, right? Angularity. So again, you can kind of start seeing how it depending on the features that you select, the software is kind of smart enough to figure out, kind of which one you're going for and kind of what you're trying to do here. If you're ever trying to edit any of these options, so like you saw here, I can just click on this and it'll give me the drop down. I can click on this to maybe change the tolerance here. Let's say I want to keep it at 40 thousandths. Right, whether you want to control free state, statistical, right? So you have a few different options here that you can select. And if you click on them, just to show you guys what it looks like, right, you can start seeing that it starts adding some of these different options, right? So again, I'm going to go ahead and click OK on this. And you'll notice that inside of my model browser, you'll see that we have a folder here for the tolerance features. Now, if you expand that, it's kind of nice enough that it lays everything out, tells you what you're selecting. So we selected 2 planar surfaces. One of them has a datum. And again, if I ever want to edit this, this profile feature, I can always right click on it, edit tolerance feature, and now it comes up here, right? So maybe I want to add a comment to the very top here. Go ahead and click on add add a little comment up there. Apply that, and now I have, kind of a comment up here. So again, kind of, you have a lot of flexibility here when it comes to annotations. Now, one thing I do want to point out is, so I'm selecting some of these features, and I'm selecting some of these annotations. Well, what standards is it using, right? So what standards does the software know? How does it know what standard to use? Well, if you go to your tools, your document settings, you'll see that it kind of points out what active standard there are, right? So again, there's these 4 standards right here. Again, so you want to be careful, right, with which standard of annotation you're going with, because that's something that's probably kind of not too easy, but you can overlook some of these options down here, right? So just a heads up there, just make sure that you select the correct standard before moving forward here. Okay, so then the next one, so I'm gonna go ahead and just apply another annotation here. So again, it's just want to show you guys how easy it is to add some of these annotations, right? So easy to add annotations, but you want to understand exactly what you're doing here. Otherwise, you're gonna, it's not gonna make sense down the line. Or if you transfer it over to your, to a CMM software, which we'll kind of talk a little bit, it's not gonna pick up the correct tolerance features here. So again, you can do the same thing here. You can say 0.04. And then again, if you ever want to maybe change, some of these options, you can always have the ability to click in and change those options, right? So this is kind of where, for me, it starts getting a little interesting. So I'm going to go ahead and add one more tolerance feature. I'm going to select this whole. And again, by default, right, it's automatically going to select that it's a simple hole, right? So again, the software knows what it's working with. I'm gonna go ahead and check this. And again, now you'll see that it has a tolerance kind of tied to it. Well, where does it take that tolerance from? Well, it's taking the tolerance from the actual sketch that I created. I'm gonna go ahead and tab, right? So with the tab key, you can kind of see that it starts switching positions. So kind of depending on what you're looking for, right? Try to make it a little bit readable for the end user here. So I'm gonna go ahead and click here. Again, whether you want, perpendicularity, maybe you want a different, maybe a different tolerance feature here, you can kind of set that as you wish here. So I'm just gonna keep it as it is. And I'm gonna go up here and actually change this to 3,000, right? So I'm gonna go ahead and apply that. So it's 3,000 now. And now a common question we get is, well, is it gonna change the actual sketch tolerance? And the answer to that is yes. So if we take a look at the actual revolution sketch, right, you can see that it changed. I believe it was this one that I selected. It was 2.875 plus or minus 3,000, right? So it does change that. Again, you want to be careful when when making a change there, so that you don't contradict some of the work that you did. But again, point being is that you do have the option. It is kind of linked to that original sketch. And that's kind of the nice thing about having those tolerance features, right? Because you can always see exactly what tolerances you apply to some of these specific features. Right, so in here you can also, let me go ahead and add two more here just so we can get a feeling for what it looks like, right? So I'm gonna click on the outer cylinder there, hit OK, and now notice that it gives me a positional tolerance feature, right? So again, I'm gonna click here, and notice that there's no tolerance kind of attached to it. So again, I'm gonna go ahead and go into the sketch, add a quick tolerance, right? And what I want to point out here too is if we take a look at the tolerance advisor, it gives me a warning, right? So 0 value tolerance, or there's some sort of inconsistency here. Well, let's go to the sketch and make a quick change here, right? So I'm gonna go ahead, add a tolerance. I'm gonna go ahead and say symmetric. And again, this is probably gonna be 4,000. Finish sketch, right? So now my warning goes away, and now I have an actual tolerance attached to the feature that I'm referencing here, right? So pretty neat. Again, it kind of gives you a real live update as to what your tolerances are, kind of your dimensions, what you're going to be, tolerancing, what kind of tolerancing feature or a model-based definition you're going to add to it. So again, this all kind of ties back to the tolerance advisor as well, or the stack up tolerance analyzer that I think we'll talk about either in a different webinar. But again, when you do the stack up tolerance, essentially it's going to look at not only the sketch tolerance, but it's also going to look at some of these model-based definitions that you guys have laid out, right? So again, when we take a look at that, it'll probably make a little bit more sense. But again, that's kind of it's essentially an advisor as well, if you can think of it. But it walks you through exactly what what the steps are needed in order to get the correct tolerances. So pretty neat tool. And again, we'll probably walk through that towards either the end of the webinar or maybe a separate webinar altogether. So I'm going to go ahead and add just a few more things here, just so we can see exactly how this works, right? So the whole thread note, I'm going to go ahead and add this to this hole here, but notice that it's picking up the hole instead of the thread, right? So I'm going to go ahead and right click here, and notice that we have the dimension type, and instead of hole, I'm going to go ahead and select the thread. Go ahead and click here. Now the only thing here is that it doesn't pick up that I have another hole here. So I'm gonna go ahead and right click on this and add the text to it, right? So I'm gonna go to the very front of this, and I'm gonna go ahead and say 2x, and then it brings it up here. One more thing with this is that it added it to the bottom of our part there, right? So I'm gonna go ahead and right click. I'm gonna go ahead and change annotation plane and select the correct plane here, right? And hit enter, right? So now it's not looking too bad, right? So now I have a few annotations. I have a few, model-based definitions here that I can go with. And, I can kind of move forward here. Now, a few more things that I can add, right? So again, if maybe I missed a few profiles or there's a few profiles that are essentially going to be standard across the board, well, instead of trying to add annotations to all of the different profiles, why not just add a general note, right? So I'm gonna go ahead and add a general profile note. Again, notice that nothing happens when I click on that, but if I hover over some of these options, right, notice that it kind of splits the view here into quadrants, right? So I'm gonna go ahead and click on the top left quadrant. My note appears, and now notice that I can, if I wish to change this, now I can change that if I wish to. But again, gives a general note that lets the end user what tolerance to apply to some of these surfaces. Now, you're not just limited to that. What if you want to do maybe a surface finish, right? So I'm going to go ahead and copy this. I'm going to go ahead and paste that down here. And I'm probably going to add, kind of a surface finish option as well, right? So copy this here as well. And there we have it, right? So we have essentially the model here that's defined here with two notes and a couple model-based definitions. Now, if you ever want to check, if maybe what's the status of some of these definitions that you added, the tolerance advisor has a pretty neat feature, right? So it has the phase status coloring option, and in here you can go ahead and turn it on or off depending on what you want to see. But notice that it's color coded, right? So again, green is going to be fully constrained, and you guys can kind of take a look here as what some of these other options are going to be, right? So constrained by surface profile. So again, being that we added that surface profile, it automatically kind of applied to everything that that we don't have. Right? So again, that's kind of the power of having the model-based definitions. Now again, there's some work that needs to be done still, so it's not, there's still a few features that can improve, but again, it's a kind of a new concept. It just got released not too long ago. So again, there's still kind of a lot more that it's going to be able to do. But essentially here, what I wanted to show too is this was actually kind of a pretty neat topic or kind of a neat I guess just thing that I came across. But oftentimes some of these features they'll change tolerance based off of dimensions. So what I mean by that is maybe this if this increases to 3 inches, maybe the tolerance gets a little bit bigger, and kind of things along those lines. So we have, or we kind of came across this rule, and I'm going to go ahead and edit the rule. But essentially, if the bore diameter increases or it's greater than or equal to 2.875, then the tolerance is going to be 6 thousandths. If anything less than 2.875, then it's going to drop down to 3 thousandths. Right. So this is kind of the rule that we came up with. Again, if you want to see what it looks like, right? So right now it's 2.875. So it's I'm going to run the rule here. It's 6 thousandths. I'm going to go ahead and drop this down, right? So the bore diameter, let's see, it drops down to 2.475. And again, I typically run rules with one single rule that calls it out, but again, we can have that run automatically. But anyways, 2.475, and my tolerance kind of dropped down to 3 thousandths there, right? So that was a question that I got a while back, and again, that is possible if you guys wish to do that. Takes a little bit of a workaround, but you can have different tolerances for different size features here. Okay, so essentially, again, we probably still need a little bit more information to get either some sort of manufacturing model for this. So you would want to go ahead and add that to to a 2D drawing and just add anything that you guys missed. Nice thing about this too is that you can actually promote some of these dimensions in the 2D drawing space. So again, you don't need to start from scratch. You can automatically promote some of these annotations, and they're going to show up in the 2D workspace. But a few more other things that I wanted to show is you can actually export this to a 3D PDF. So maybe you're done, you want to export this out. Again, you have a few options, right? So what do you want to export? Do you want to the title, subject, author, kind of go along with it? A couple more other options here that you can select from. But anyways, if you had a 2D drawing that you wanted to kind of send this along with as well, you would click on attachments, select the 2D drawing, and kind of send that out as well. But anyways, I'm just going to go ahead and publish this. It does take a little bit of time to generate, but it is going to generate kind of a pretty neat 3D PDF here. Right, and so here's a 3D PDF. Again, some of you guys may or may not be familiar with it, but again, you can rotate the model, you can take a look at the annotations, and you kind of see how this model was made, maybe some of the tolerance features that got added, maybe something needs to get revised, you can send it back. One thing I do want to point is that you do want to, and I didn't do it in this case, but you do want to have a different view for it. Again, I probably want to do that in the master view, probably create a new view for it, and then generate the 3D annotations that way, right? But not only can you do 3D PDFs, again, you can also export this as a step file, and export as a AP242 file, right? So again, if you're going to export this out to a CMM software, maybe something along the lines of Power Inspect, maybe a different CAM software, you can do that, and it's going to export with all the model-based definitions. So again, if that's something that you're interested in, or maybe you wanted to learn a little bit more about, feel free to give us a call, and we can go ahead and kind of walk you through that here at the end. But yeah, that's kind of just a quick rundown. Again, I just wanted to give you guys a quick overview of what the kind of the model-based definitions look like, some of the capabilities. Again, if you guys have any questions, we'll be here for questions. There's our emails. If you guys need to reach out, just either reach out to myself or Nigel, and we'll do our best to get back to you guys here. But yeah, Nigel, any questions that came in?
Yeah, absolutely. And Alex, if you want to just go real quick back to your inventor there.
Yeah.
And if you noticed a couple of versions ago, not you, Alex, but everyone listening, you might have noticed a couple of years ago, they did add view representations to part files. That used to be a thing only in assemblies. And the reason they did that is for this specifically. What Alex was talking about a little bit earlier when he was talking about the 3D PDF and adding different views to be able to represent some of these features, is if you expand the view representation, you add another one. When you create those annotations on those specific views, they only apply to those views if you set it up that way. So what you can do is what I do is I set up views for like the top view, set up views for the side or maybe the left or the right views. And then when you create that 3D PDF, if you pull the view up in that particular orientation, you only get the ones that you're really concerned about in that direction. So just in a little FYI to people, if you're looking at using this in production and stuff. Another thing too that I've seen working with 3D PDFs, not 3D PDFs, the 3D annotations, is in the tolerance advisor. I believe if you right click it, Alex, one of those errors.
One of these errors? Yep.
Yeah, so if you click that, and this is just, playing around. Did it open a browser window? Yeah. So it'll open a browser window for you that goes directly to Inventor Help. And the Inventor Help will pull up like, oh, what does that particular error mean? And let me go ahead and solve this. What does that actually mean? How do I fix this? Et cetera, et cetera. Like we said earlier at the onset, this isn't a webinar to teach you what GD&T is.
Yeah, that's a whole different.
Yeah, exactly. But if you do need to know what's going on, this is a really good resource to do so. So that covers, I guess, a couple of questions, as well as just a couple of things that I know from working with the 3D annotations over the last couple of events, last couple of releases here. So let's see, what else do we got? Alex, have you played around with having the dimensions controlled by like external parameters, like an external source, whether that's an Excel spreadsheet or whatever? Does it react the same way? You would just use an iLogic code to update the tolerances and stuff?
Yeah, so it would update the same way. The only thing that I would be cautious of, so you can't have parameters set to be inside of the tolerance, right? So the tolerance is kind of built into itself, which is kind of why I had to do this workaround. So I have this tolerance parameter, and again, oftentimes you'll see a lot of companies, they don't really want to do this. But if you only have a few features that do require different tolerances, then this is kind of the only workaround that I've been able to find, is create a tolerance parameter, but you're not necessarily using that for the tolerance itself, right? So we're not using the tolerance parameter in here. It's essentially something that now you can add to this, to essentially this little snippet here that we have. And if you want to know where that's at, it's going to be over here on one of your snippets here. I'm not sure exactly where it's at. I forgot, but essentially what I'm doing here is now I'm calling that parameter, right? So now I'm calling the single parameter that I made, and then I'm converting that. But essentially that's what's now being placed inside of the symmetric tolerance that I have. So yeah, I mean, if you're going to work with parameters and kind of import them, or importing them from Excel, then it works the same exact way, right? You would just have an iLogic rule, control these parameters or these dimensions with the Excel spreadsheet. But if you want to change the tolerance, you want to be a little cautious about that, because it's not going to work as you would expect, right?
Absolutely. Yeah, and this was just the 3D annotations in general is just something I saw a couple of years ago in the beta program, the Autodesk pre-release program for their applications. And it was something that really kind of struck my eye as like, okay, this is totally game changing. As a little tie in there, if you want to look at some of the new stuff that Autodesk is planning on releasing or working on for the next couple of releases of whether it's Inventor, Vault, Revit, whatever product you use every day, they have beta programs for that. And we also host live events for that. So if you want to see some stuff that's coming out and you're in SoCal, definitely reach out to us and see if we can find you a seat there for our Inventor Insider event that's coming up here in the next couple of weeks. I can't tell you exactly what's in there, but I've seen it and it looks super sick. To use like a terrible way to describe that. But I think some of the stuff that they're showing this year is going to be super game changing for a lot of the companies that we work with. So if that's something that interests you and you kind of want to look towards the future, definitely reach out to us for that information. What else is there? One more thing too is I see that we have some of our friends from Autodesk on the line here as well. Our friend Paul Norman being one of those people, and Paul works, partially on this team as well for the 3D annotations. So Paul also works on the group that puts together a lot of the guided tutorials in Inventor, and we've done an AVA about that before as well. There is a guided tutorial for 3D annotation specifically. Alex, can you browse to that real quick for me?
Yeah, let me see if it works. I think.
Yep, and there's a ton of tutorials in here. You can publish your own if you want to know more about this. We did a full AVA on all of this, but I think if you just search 3D annotation, there's going to be a ton of them.
Yes, so there's one here. I think I've seen another one here, right? So create and analyze tolerance features. So there's a few of them.
Yep, there's a decent amount. So if you want to learn more about this feature in Inventor or just a bunch of other stuff, whether it's like the design accelerator, whether it's new ways to create drawings, there may or may not be iLogic ones in there, I don't know. But there's a ton of guided tutorials in there. And it's just, people at Autodesk putting these together, people like you and myself, who just feel like we want to share some knowledge with the world, go ahead and drop those in there as like public as well. So, it is the community that's putting a lot of this together. So really appreciate any feedback that you guys give for some of these, as well as, things that maybe you see are missing and you want Autodesk or ourselves or yourselves to generate in the future. But that is where I would go next if you were looking at further going down the rabbit hole to start adding some of these annotations to your drawings or your models in general. And I think it's really useful. Alex works primarily, not primarily, but works a lot with some of the manufacturing sections of our customers, whether that's people actually coding their machines to be able to post parts out. And I think this would be super useful for a lot of those people. Wouldn't you agree, Alex?
Yeah, no, definitely, it definitely is. And again, that, kind of like I said in the beginning, the end goal is going to be essentially to probably start limiting some of the 2D drawings. And I know, I guess, that's I guess a scary thing for a lot of people, but essentially just having one source of truth here and just kind of having everything tied to this model, I think it is pretty huge.
Absolutely, absolutely. So it looks like we have that's just about it for all of the questions that we do have. But if anyone has any more, I'll give you about 30 seconds to ask any more questions that you do have while making a couple of announcements here. So in a couple of weeks, we've got a special AVA where we're going over kind of prepping your inventor models for analysis, whether that's FEA, CFD, etc. We're kind of diving into that a little bit with the combination of Inventor and some of the stuff that our ANSYS partners help us with as well. So if you're interested in figuring, and a lot of it is applicable to just about any simulation solution out there. So if that's something you're interested in, if that's something you're looking at, definitely stay tuned for that one specifically. In addition, there's 3 or 4 iLogic topics that are going to be happening here in the next 8 to 10 weeks. I just need to figure out the scheduling for those up until about, I guess, Thanksgiving. That's crazy. But expect to see some of those on your calendars here moving forward as well, whether it's iLogic and Inventor or using some of the VB stuff in the VB editor. Stay tuned for those. But Alex, I think that's everything for questions. Do you have anything to add before we let everybody go today?
No, that's it. Just want to thank everyone for tuning in. And again, if we didn't get to your questions or something comes up later on, just go ahead and feel free to shoot us an email and we'll answer those off air. We'll be glad.
Absolutely. And if there's more stuff you want to see Alex do in the future, let us know via email as well. I'm sure Alex will get really excited for any topics that you guys think he should be doing or anyone here on the team should be doing because sometimes we just need some help figuring out what to do next, whatever you guys want to see. So again, thanks everybody for joining us. Alex, thanks again for spending the time with us this morning. We'll see you all next week. Thanks, everybody.
Mm-hmm.